Hey everybody, it's Dr. D. It's good to see you again. Today I want to talk to you a little bit about the data handling problems from problem set 2. Here I've already entered my name. You feel free to enter yours and my 900 number. Again, you want to make sure you enter that stuff too. Some of the questions, the numbers might change as you enter those. Just want to give people a chance, even if you're working in groups, to try to make sure everybody's doing their own work. The ones I want to focus on today in class, if you want to go look at the videos from in class, or I'll post other videos later maybe if you didn't see the one from class. But we worked on some of the more straightforward problems where it's a word problem and it gives you the material that you need. What I want to talk about today is stuff where we're dealing with the tabs that have problem sets. So let's look at number 8 and 9 maybe. We'll at least walk through how to do them, if not actually do them together. So for question 8, for the questions below, consider the pet health worksheet. Clean the data before addressing the below. So I know this is going to be new to some of you. We didn't talk about this before. So what do I mean by clean the data? And I'm actually going to create a new version where it's I don't think I can. I think it's protected here, but I do want to show you what the differences are between cleaned and uncleaned. So I'll try to make it so that you can look at it both ways. Let's see what we have here. I'm going to make this big for a minute. If we look at this pet health data set, you can see it's not uncommon to get a data set that looks something like this, where very clearly, this was a data pull that had some things in here that were designed to, I don't know what it's for, maybe to make it easier if you print it out to take a look so that you don't just have a undifferentiated massive data. But in any case, Excel is going to have problems with all of this non-numeric data here. All these dashes here you're familiar with. These things right here are called pipes. And if you want to look for them on your keyboard, they're above the enter key. You should have a backslash key. If you press shift backslash, that creates a pipe. So that's where that comes from. And they're really nice if you want to make a vertical line, but they cause problems when you're trying to do data analysis. For example, I don't know if it's going to happen if I do some of this. I don't know what happens. Anyway, we got some data formatting issues. If you try to run regressions, is in particular, which we'll get to later, having that non-numeric data will cause problems. Now, it is nice that we have these headers here, but it's still a problem. Now, I do want to show you what it looks like when it's clean and when it's not clean. So I'm going to copy all of these unclean columns over here, just so that I can do it both ways, so I can show you kind of the difference. And now I'm going to show you kind of how to clean the data. Probably the easiest way to clean the data is just to delete these first couple rows that you definitely don't need. So what I'm doing now is I'm selecting this data, I'm right-clicking, and then you can click delete, or I usually press D. And then it'll ask you, if you didn't select a whole row or column, you want to shift the cells up or shift them left. You can change what you want, or the entire row or column. In this case, I have more stuff to the right that I don't want to mess with, and so I really do want to shift the cells up. So that's what I'm going to do, and sure enough, those are fine. Similarly, with these columns that are annoying, since there's only 1, 2, 3, 4, 5 of them, the easiest thing to do, if you go to the column header, any column header, if you right-click on it, you get the context menu up, and you can do stuff to it. I'm going to right-click and then press D. That'll delete it. Right-click D, right-click D, right-click D. And it's actually a little easier if you go from right to left, because then the whole thing's not moving. So just to kind of show that again, if I go over here to the right, right-click D, right-click D, right-click D, right-click D, right-click D. That gets rid of all the columns that had kind of junk in there. Now, to get rid of these dashes, well, I didn't actually let you see the data first. If we zoom out, you can see that what we have here is we have a lot of data, which is one of the reasons that I want to that I include this exercise in the problem set. This is much more like a data set you might encounter in real life, where the data we're dealing with in the problem sets, they're useful as teaching tools, but at most maybe we have not 20 observations or 100 observations or 200 observations. This is more than that. And you're actually trying to deal with the data. So let's take a look at how to do this. You can see that there are just a lot of dashes. You can do the right-click D thing if you want. It's just going to take you a long time because there's 100 of them or so. So what I find is more helpful in this case is to sort the data. And if you sort the data, all the trash will move to one end or the other. When you sort the data, usually you want to pick something that's sort of somewhat intuitive to put in order. It doesn't have to be. You could put it in order by animal code. You could put it in order by the browser type or the client browser. But often when you have data that includes dates, I don't even know why these aren't unsorted to begin with. Often you want it to be sorted by date. So that'll be, if we ever wanted to put in a line graph, it would be nice and natural to have the data sorted by date. So I'm just going to sort this by date to begin with. So the way to do this is to select all of your data and then to go to data sort and then to do it that way. And actually I'm gonna walk through what I'm gonna do before I do it, because when I do it, it's quite fast, partly because I've done this so many times. So what I always do is I select the top right. Often this is A1, but it's not always. Sometimes you have a header row that's useless. Excel requires you to have only one header row. So you want the top right, by which I mean the first cell of the bottom header row, the last header row. And then, assuming that you are not missing any data, and that's a big assumption, what I'm then going to do is press Control Shift right, and then Control Shift down. And the purpose of that is just to select all the data, right? So what that's going to do is it's going to start with one cell, and then it's going to expand the selection to include, the entire row. And then when I press Control Shift down, it's going to expand the selection to include the entire data set. Now, if you are missing some data, sometimes you have to repeat one of these things, because if you press Control Shift down, for example, and let's say your last column is, I don't know, maybe it's email address and some people didn't fill it in, and you have omitted data, you might press Control Shift down a bunch of times. And in those cases, maybe it makes sense to do down first and then right. There are ways to make this work. All of this, the goal of this is just to select all. And Excel's actually gotten better. Another alternative here is to press Control A. And Excel over time has gotten better with this, but sometimes Control A is disobedient. And so I usually use Control Shift down, Control Shift right, Control Shift down, just because I know what it's doing. Control A feels a little bit more like a black box to me. All right, once that's done, you can click on Data Sort. I'm not going to. I showed you where it is, right? It's right there, Data Sort. I press Alt D, and then I press S. So not combined, but Alt D together and then S. That's a shortcut key for data sort. I sort data so often. One of the things you really want to do with Excel is get in the habit of not taking your hands off of the keyboard onto the mouse and back again. If you can keep your hands on the keyboard, the more you can do that, just the faster, the more comfortable it will feel. So again, you'll see me, I'm going to press Control Shift right, Control Shift down, Alt DS. So Control Shift right, Control Shift down, Alt DS. And that brings up this sort. And you can see if I really wanted to, let's see, if I double click this, does that work? Oh, no, that just fills down. That's not what we want. Control Shift right. If I press Control A, that does work. That gets us where we need to go. So Control A works in this case. And then I can click on Data Sort. But Alt DS is how I prefer to do it. Just what I feel comfortable with. Now, when we get to sort by, you can see Excel tries to figure out whether you have headers or not. It doesn't always work. In this case, it does work. And so my data has headers. Once I have that, then I can choose what. If you don't have that, it just lists the columns here. But I do want that checked because I do have header data. But if you're just doing rough and ready data, sometimes you don't have headers and you just want to play around. You can sort without it. And then you can see that if you have headers, it uses the header names to populate this drop-down box, which is convenient. I want to sort by date. I'm going to go oldest to newest. You can change that. Sort on the values. You can sort on colors too if you want, if you ever need to. That's a useful thing to know. And then I click OK. And then there you go. We've got our data sorted. You can see the first data item, whatever, first observation came in October 3rd, 2007. And then as we scroll down, you can see we're collecting data on a irregular basis. Maybe these are sampled on a certain set of dates. And then if we press page down I'm pressing page down. You can see it goes on for a while. I want to get all the way to the bottom. So what I'm going to do is I'm going to press Control down. And that's going to go all the way to the bottom. Here you can see where all the junk ended up. The reason that we did this is that this is an easy thing to deal with. Oh, by the way, I want to make this big because it's annoying to me to only be dealing with half of my screen. Windows key up lets you kind of go like this. But if you press Windows key up twice, Windows key up makes it maximize. Windows key left, Windows key right, Windows key right, Windows key left, Windows key left. Windows key down, Windows key up all the way, and now I have a full screen. So that's convenient. I find it convenient. I use it a lot when I'm trying to deal with multiple. I've got a 2-monitor setup you can't see, but when I want to move things around, Windows key left and right and up make it easy to maximize and move things around. Okay, now I want to get rid of all these dashes. So I'm just going to press page up till I get to the end of them, and there we are. So that's the end of this. If I if I go to the top set of dashes, I'm going to do the same thing I did before. Control Shift right, Control Shift down. And I just want to get rid of this, so I'm just going to press the delete key, and those are gone. Now what you see is I have clean data. So when I said clean the data, that's what I meant. I meant get rid of all the dashes, get rid of all the pipes. If you're doing it from scratch, I'm going to undo all the stuff I did just to show you kind of how fast it goes if I'm not dealing with like zooming in and deleting everything. So that's what the data, actually, this is what the data started out looking like. So when I say clean data, if I'm not teaching this, what does it look like? Well, I want to get rid of all this stuff, so lift that up, right-click D, right-click D, right-click D, right-click D, right-click D, Control-Shift right, Control-Shift down, Alt-D-S, sort by date, okay, Control down, Shift page up. And so there you go. Less than 30 seconds, right, just to get it all. Control Home goes to the top, so that's one more that's worth putting on the list. Whenever you're done, you can always press Control Home. It's a nice way to just get yourself set up for whatever comes next. And if you're like me, when you started, you don't even know where the Control Home key, where the Home key is. You have to look for it. But once you practice and you're doing this regularly, it's just a button that your hand learns to find. So you practice that. Okay. So now we're ready to go back to the question with our clean data. What is the sample size for the pet health sample? Well, we looked at one like this on problem set 1, and we learned about the count and the count A formulas. In this case, we're going to use equals count, and we can use the pet health data, and we can count just the ages, and that'll be fine. We count the ages. You can't count any of these. You can count any of these. If you count one of these, the problem is it's going to give you 0, because count only counts numeric data. So just to show you, that comes back as 0, so that's not what I want. Okay, and I realize I'm moving a little fast, so maybe a lot fast. Equals count. So what I do is I press equals count, I press tab, and that automatically puts the parenthesis in. Now I'm pressing control page down, page down, page down to get to the right place. Control home gets to the top again. And then because it's count, I want to find some numeric data. My site visit length data or my age data are fine. I go to the first one, I press control shift down, and then close parentheses, and that should give me the result. Now another option would be to use count A, not that. Here, let me get that formula for you first, actually. So this is one way to get the answer. Another way would be to use count A, and then go over here. Now this counts alphanumeric data, so anything really. This works over here with these record ID, whatever ID code this is. So if I press Control Shift down here, that'll give me the right answer. And that's nice. I mean, that's a nice thing, nice feature. Oops, I didn't mean to do that. There we go. So count A works. Now let me show you with unclean data what happens. So if I use count on the unclean data, and so now you probably don't have this, but if you do, then great. I can go to the first age, just like I did before. And if I press Control Shift down over here, the nice thing about count is because it only counts numeric data, it gives me, oops, it gives me the same result because it's just skipping dashes. But if I use the count A formula like I did in the prior one, with this, I can do it by continent, but I'll use the ID just like I did before. So we're doing apples to apples comparisons. You can see that now I have an incorrect sample size because that is the number of rows that are non-blank essentially, and that includes all those dashes. And you can see that there are almost 300 dashes. We don't want those. So instead, just any of these is correct. 5540. Okay. Find the record below. What is the z-score for site visit length for that record? Well, to get a z-score for an individual record, we're going to need an x, and then we're going to need an x bar, and we're going to need an s, because the z-score for samples, and this is a review from BUSA 2000, but it follows the same intuition. We're going to take x minus x bar over s. Last time we learned about x bar, we're going to use equals average for that. And then we learned about s. We're going to use equals stdev.s for that. And then we need to find the specific x. But first things first, we can find our x bar, we can find our s, because all we need is the site visit length for those. It's nice to have the cleaned data. So equals average. And the site visit length data is right here. This is the site visit length. So what I'm going to do now is I want the average of all of these numbers, J2 to J5541. And this is in microseconds, or milliseconds, not microseconds, I think. So if we go here, you can see, yeah, site visit length, ms, milliseconds, which means the average person stays on the site for about 51 seconds. Now, I could do the same exact thing with stdev.s and then go and click through. But one of the things that's nice about Excel, or, is that one of the things I find convenient is if I have a formula, I can just modify the formula. So since this average is what I want to do the same, or this range is what I want to do stdev.s with the same thing. So a convenient shortcut key in Excel is F2. F2 toggles edit modes. And there are actually a couple of edit modes. There are 2 edit modes. One makes your arrows move around. So right now I'm not in edit mode at all. When I use the arrows, I move around here. When I press F2, now when I use the arrows, I move around in the cell. And when I press F2 again, now when I move around on the sheet. Actually, if you're not here, it kicks you out of edit mode. But if you're in here, see, now I'm moving the cell around, or moving around within the cell, the cursor. But if I'm in here and I press F2 again, now I'm allowed to move my selection. Like, what is that going to look like? So F2 does 2 things. It both lets you edit a cell that you're currently in, and then if you're in a part of a formula that requires a range, it lets you to navigate to select that range. In this case, I actually don't want to modify the range. I want to modify the formula. So what I'm going to do now is I'm just going to select everything in here. If I press Control-Shift-Left, it jumps back just like it does within a cell. I'm going to select this whole thing and copy it. I want to copy the formula because if I just copied and pasted the formula, some things would change. We haven't talked about absolute and relative references. When we get there, you'll learn more about why I want to be very careful here. But that's fine there. Now I'm going to press F2 again, so I'm editing this, and I'm just going to paste it here. Now, if I press Enter, it's just the same formula, right? So now I just have the same formula in both of these. But I don't want the average here. Instead, I want the stdev.s. And sure enough, it gives that to me, right? It gives me the standard deviation. And so now I have 2 parts of my z-score. Now I have to find this record ID. I'm going to press F2 again. Ooh, it doesn't work if I press F2 again. I guess I'm just going to have to type that. So I'll make a note. I'm not sure how much of this I need. I got pethealth.com 2011621_116. That might be enough. If not, let's try .99. If I go to Pet Health and I find that, what I'm going to try to do is I'm going to try to find it twice. If I only find it once, I'll know it's unique. So to find, you can go Control F. That pulls up the find screen. Control F. And then, let's see, where is that? Oh, it's on my other monitor. Grab that for you. There we go. PHC 201162116.99. Could not find what I was looking for. I copied something wrong. 20162. Curiouser and curiouser. Let's try it again. Oh, it's because I'm searching within that. I had more than one selected. If you have more than one thing selected, it'll just search the ones that you have selected. There you go. Now that I have that, now that I have or I have one cell selected. So yeah, let me show you why it was going wrong there. If I search for it in here, and then I pull up my find and replace right there, it'll say, hey, we can't find it. If I click out of that and just have one cell selected, now it searches the whole sheet. So find next. There it is. So that's PH601201162. If I search for it again, that's the only value. I have one in the dirty file and one in the clean file, but that's fine. That's a sufficiently unique identifier. Okay. I wanted site visit length, and site visit length, if I recall, is J. So that looks like it's J1539. Yep, J1539. So I'm going to pull that over here. Equals Pet Health J 1539. Sure, there's the fastest way. Actually, it's not the fastest way. 1539. There you go. 108.30.321. That should be what I need for my z-score. Let's try it. We got 108.321 minus x. Actually, let me give you the formulas before we move on. That's one formula. That's the next formula. And then I'm actually going to move this one up here. I can, that formula, that's my S. It's my S. All right, so we got x bar, S. That gives us what we need to calculate our z-score. Your numbers might be different here, obviously, but in any case, what you need to do is take your x minus your x bar, divided by your S, and that should give you your z-score. Let's show you that formula again. So you can see it's just like a z-score formula, except we're using a sample instead of the population values. And that should give you the correct answer. Now, if you had the problem set earlier and cleaned it, you might get an error here. I updated it with a new version. You can try to, download a new version and check your math if you want. There was just a problem with the VLOOKUP function, but it's fixed now. But yeah, so that, take a look, see if you get it right. Intuitively, it should look like, you got 51 grand minus 100 gives you, I don't know, 51,000. Divided by 79,000, that's 5/8, but it's negative, right, because you're subtracting that. So negative 5/8, and sure enough, it's close to that. All right, what is the standard deviation of the sampling distribution for age? Well, it would be sigma over the square root of n. But instead, we don't have sigma, right? We have s, and so we can use s for the square root of n as an estimator. And that number is called the standard error. So I've got n here. We're going to estimate the standard error, which is just a fancy name for the standard deviation of the sampling distribution. So s, or n, we already know, right? Because we figured it out a couple times here. It's this 5540. That's from counting the ages. For the s, just so everybody's aware where that comes from, for the s, we need to use the stdev.s formula. Let's go down to pet health again. We're just looking at ages. And the standard deviation of ages is 25.94. Take this number, divide it by, not that number, but the square root of that number. And hopefully, that'll give us the standard deviation of the sampling distribution. Sure enough, that's correct. All right, so those are how you do the ones for problem 8. Let's look at problem 9 just to walk through them. So for this data set, or for these questions, we want to look at 9A, 9B, 9C, we want to look at the B weight data set. This is a public data set on birth weights and cigarette taxes. The idea being that if you increase the cigarette tax, it decreases cigarette use, and then that leads to increased birth weights or whatever. That's what the data set's about. To play with it, we want to look at the average cigarette tax, the standard deviation cigarette tax, and then that's going to be mu, that's going to be sigma for 9C. We're assuming they represent population parameters. And then this 9C is just like one of the previous problem sets. So hopefully it's clear that what you're going to be using here is like equals average of something, and then here you're going to be using equals stdev.s of something, and then we need to figure out what that is. So let's take a look here. B weight, we've got family income, sig tax, sig price. Assume those are in cents. I don't think it's $120 to smoke even now, and certainly not when these were created. Birth weight, father's education, mother's education. Arity, I think that's the birth order, like how many, which child you were in the order. Male, whether the baby was male, whether the baby was white. How many cigarettes somebody smoked. What the birth weight was in, that's the log of birth weight. That's the birth weight in pounds. Number of packs, so that must convert these cigarettes into packs. I think, yeah, that's a straightforward. How many cigarettes do you smoke a day? 10 is half a pack, 20 is 1 pack. And then over here, log of family income for statistical reasons. Those can both be useful. But looking at the sig tax, that's what we're looking at here. And so I think if we just use equals average, this is already cleaned, of the sig tax. Sure enough, that gives you the right answer. And then equals stdev.s of the sig tax. Same deal. So let's give you the correct answer. With those numbers, you should be able to set up the, that you got your mu x bar. You're going to need to calculate your sigma x bar based on your n. You need to use equals count to get your n. And then once that's done, you should be able to do the 4 steps just like we've done before. Okay, so hopefully that gives you enough to kind of see both how to play with some data, how to get some results, to clean it, and then how to do some of the types of problems we've been dealing with if you had to go get your data on your own. Where we'll go next, we'll get rid of our last two terrible assumptions, and then the numbers we generate will actually be new and improved contributions to the state of human knowledge. So I'm excited to get there with you. I hope you found that useful. If you have questions, as always, please let me know. I'm happy to help. I'm Dr. D, and good luck. Keep in touch.